Again, we're at problem number 11, so I'm just going to kind of talk about some of the details that I think you should be aware of. One is that 44 is actually 4 times 11. And this minus 12 is actually minus 4 times 3. So I'd have to multiply the top equation by 3. That's if I want to use the Wells technique, getting 0. And the bottom equation by 11. All right? And what would you get there? You would get, let's do the top. You get 6 over x squared plus 3 over xy plus 15 over y squared is equal to 3 times 4 times 11. Let's do 11 times the bottom equation. What do you get? 11 over xy minus 11 over y squared is equal to, let's see, minus 3 times 4 times 11. If you add these together, relatively simple, you get 6 over x squared plus 14 over xy. And then what do you get over here? Plus 4 over y squared is equal to 0. Well, I'm going to simplify a little tiny bit. And again, I'll talk about my key in a second, by dividing by 2. You would get 3 over x squared plus 7 over xy plus 2. I'm dividing by 2, right? I almost forgot what I was dividing by. And I'd factor it. And what do you get over here? 3 over x. If it's to work, it's got to be easy. If it doesn't work, I'd go to the quadratic formula to do it, which would be tough, I'll be honest with you. Let's see, I'd say 2 and 1, right? 2 over y and 1 over y plus plus. Does that work? Well, you do get 3 over x squared. You do get 2 over y squared. And 6 plus 1 is 7. Works like a charm. So I'm going to write this down for you. And again, we're just reviewing. I'm not going to do every step for you. So 3 over x would have to equal minus 1 over y. And the other answer would be 1 over x would equal minus 2 over y. I'm going to rewrite this as x over 3 equals minus y. That's relatively simple. And this would be x equals minus y over 2. All right? And I'm going to just rewrite them a little bit differently. I'm going to write the second one as 2x equals minus y. Whoops, minus 2x equals y. Let me clean that up. And this over here, I'd write down x equals minus 3y. So my claim over here, these really aren't bad. Like this one's not bad, that one's not bad. Which of those two equations would you use? Probably this one to solve for x and y. Relatively simple, by the way, all right? Now, certainly, I'm not going to do it because we've done so many problems prior, and it would just be the same sledgehammer over and over again. But this is not being displayed in the key over here. At least I don't believe it is. No, it's not. I take a more traditional approach, though, in the key. And, you know, bottom line is, what I did in the key was I just simplified the system. You know, get rid of the LCD, multiply both sides with the LCD, yada, yada, yada. You know, and then follow these steps over here. And again, your goal is to be able to identify each of these steps over here, right? That's your goal. Now, someone says, well, no, I just want to look at the answer and see if it's a correct answer. You don't know what's the correct answer until you go through the steps. So I want to point out, just kind of looking at it, relatively simple, by the way. Multiply both sides by the LCD. You should be able to verify that pretty quickly. What's the LCD in the first equation? X squared, y squared. All right? Relatively simple. Second equation, what do? Multiply both sides by xy squared. Very simple. All right? So you get, yeah, looks good. All right? So what do you do now? Well, you take that second equation, solve for x. And then you take that, you plug it into the first equation, which I did over here. And so far, it's really not much work. This is going to be the work. This requires work. And a lot of it, or in my opinion, a lot of it. And then the factorization is also going to require work. What do you get over here? Some really simple answers And let me go through that. What are the y's going to be? Well, one of the y's could be 1/3. That comes from this one over here. One of the y's could be minus 1/3. That comes from over there. Another y could be 1/2. That comes from that one there. The other y could be minus 1/2. How do you get the x? All you have to do is plug it in here. If you do that for 1/3, you should get this. For minus 1/3, you should get this. For minus 1/4, you should get this. For minus 1/2, you should get 1/4. All right? Then what do? You look at it, and it's going to be a graph. I'll point out what the graph is. The graph's over here. Not an interesting looking graph, but there's 4 points of intersection. I want to just give you an aside. I actually, sometimes when I'm doing the problems, I wonder, did I really get it right? And I use a computer. Like, did I second guess myself sometimes. I asked Sage to do it, and Sage actually gave me an answer that was incorrect. It said x equals y equals 0. Now someone says, I wonder why I did that. I don't know. I don't know why I would have said that, because clearly that can't be the case. Why is that? You couldn't have a division by 0. I think perhaps, though, it's doing something like manipulating the problem, and it's seeing something that's not there by manipulation. Like if you manipulate this over here, let me point out what I mean by that. If you looked at this over here, clearly, if you looked at the answer to that is 0, 0. The answer to this is also 0, 0. But it's not the answer to this. It's not 0, 0. So be aware of that. Be careful of software. It can return a very, very bad answer. Okay, let me just remind you who I am. I'm Ron Bannon. Email address is Bannon. Let me write that down for you. Why do you need to reach out to me? Maybe you see something. You want to say something. And again, with the intent of improving the document. Thank you.